So you can see my screen as well, right?
Yep.
Okay, nice. Okay, so I guess we'll start the session. So welcome everybody to this session of the Eclipse Che, Kubernetes native IDE for developer teams. So my name is Mario Loriedo, and I'm a software at and so I work on Che since now almost 5 years. So I've been working since the first day I joined Red Hat. I've been working on Che, and so I'm excited to talk about the project and the latest evolution that we have done. David, do you want to introduce yourself?
Yeah. So hi everyone. Hope you're having a good KubeCon so far. Thanks for joining us on the Eclipse booth. I'm David Harris. I'm a new product manager within Red Hat. I've joined from IBM, where I had been working on similar technologies for the Cloud Pak for applications. I can say the same as Mario in that since I joined Red Hat, I have also been working on code-ready workspaces, our productized version of Eclipse Che and the Che project itself. So really excited to be here today and show you what it can do.
Cool. So first of all, so let's start with an overview of Eclipse Che and what actually it provides. So what problems Eclipse Che is able to solve. So we're building an IDE that first of all should help developers that are targeting Kubernetes as their deployment platform. So something that makes it should be an IDE and development tools that makes it zero effort to deploy, to start developing on Kubernetes and to deploy, to test the application they're developing on Kubernetes itself. So Che runs on Kubernetes and help developer run its application on Kubernetes. And as we're gonna show you, so a developer can start coding in a few seconds. It's a matter of the time that an application, so a pod starts with the IE, and the developer will be able to be productive. Second thing that is important is the security. So we want to build a tool, an IDE that doesn't need for the source code to transit on a developer laptop. The source code can live on remote on the Git repository, on the Kubernetes cluster, but doesn't need to go into the developer laptop, as well as other development tools. So the developer doesn't need to install locally tools, and every tool, every framework that a developer will use is actually something that is running on Kubernetes and can be enforced, and so that we make sure that the development tool used by a team are compliant with a company standard and limitations. And lastly, so we want to have repeatable development environments. So development environments that are defined as code. We want developer to save the configuration of their development tools with their sources on a Git repository. So we'll see that we have a file format that allow a developer to specify in a few lines the tools that will help to build, run, test, debug its application.
Yeah, so I think one of the reasons why we think this really appeals and why we've seen a number of Red Hat customers and community users take to Che is kind of like around two key use cases, I would say. So one is around like quickly onboarding new developers into teams, and like that is not so much an enforcement of which tools you're using, but it's easy provision of them. So you can think particularly if you're working with contractors in your organization, you need to get them on board quickly. This provides a really nice, easy mechanism to do so. It is Kubernetes native, as Mario's suggesting. And I think we can all kind of agree that Kubernetes does have a fair learning curve, and some developers will spend the time to gain really in-depth skills and knowledge and awareness of the platform. Others just want to code. So this is quite a nice way where you can help those developers build and deploy on Kubernetes from day one and hopefully catch issues as a result of your target deployment platform earlier in the process. And obviously, the sooner you find a problem, the cheaper and easier it is to fix.
So how do we do that? So how does Che works, and how does it help solving those problems? So first of all, so we have already mentioned that, and I think that so people that know the project already know that. So the Che is a web IDE. But more than that, is a web IDE server, in the sense that in the image that you see on the left is the first page that you see when you land on the Che web page. You have a list of development stacks, so some getting started example of different stacks, and as soon as a developer clicks on one of those examples, an IDE will be started in the browser, as well as the IDE as well a backend component. So an Node.js application that actually powers the IDE will start on the Kubernetes cluster, and the result will be what you see on the right. So one full IDE with everything you would expect from a modern IDE, but running on your browser. So if we look a little bit more into the details here, is we have a central Che server, actually, that is every time a developer requests an IDE or workspace, it actually starts a new pod that is with a lot of containers inside that altogether makes it a full IDE with language support and with other tooling, and we'll see what different tools will Che is able to run. The important thing here to see from that slide is that Che is actually multi-tenant, so multiple user can query the Che server for a workspace, for an IDE, and those IDEs are based on TIA. So Eclipse TIA is another Eclipse project that actually is an IDE framework that we use as our default editor. So the default look and feel that you see in the browser is TIA look and feel, and is really close to Visual Studio Code. It has the same the same flow, the same way to work as Visual Studio Code, and it supports Visual Studio Code extension. So we can run on that using TIA. We are able to run Visual Studio Code extension in the web, in the cloud. But that's not the only option. So you can also Che is able to start a workspace with another front end, and we have a proof of concept that is probably now a little bit more than a proof of concept, that is the IntelliJ based IDE. So we, as soon as the developer select to start such a workspace, a container running IntelliJ started, and we're able to show the UI of IntelliJ from within the browser. So and those workspaces are isolated in their pods and are isolated by namespaces, and so every user developer is as his own namespace, is not able to access the resources of other users. So we're able, the developer can use their credential to get access to Maven repository or Git repositories or container registries, using their credential that will actually be stored as Kubernetes secrets and not accessible to other users of the same Kubernetes cluster. But that's is more about how the workspace is the components of the workspace. So now we are zooming in the workspace. So when the Che server start the workspace, it actually starts a pod, the workspace pod, and all the little square that you see here with colors are actually the different containers that are run into the workspace pod. So you can compose that. So usually you have at least one editor container that runs an editor. The default one, as we say, is Eclipse Che. And then you have other sidecars that you can add to that workspace pod, containing language servers, so supporting different languages, or CLI tooling containers with all the tools that you need for building and testing the application. And these are actually all isolated from the application container, where actually it's the container that you use in production to start your application. So we are sidecarring the development tools to an application that runs on Kubernetes. And as a result, from your browser, you will be able to connect to the editor container that will expose an ingress that you will be able to use from your browser. And all of this is, of course, authenticated with different identity providers. So I guess that's basically it for the sidecar architecture. The last thing is we have talked about the development environment as code. So what does it mean? That means that we have, with a YAML file that we call dev file, you can in your development environment with first section is the project section, is like the source code that you want to clone in your development environment. And then a list of components, and components are the sidecar containers that will compose your development environment. And in the example that I have here, have two components that are two containers. The first one is a Maven, is a Maven container. The second one is a MySQL running that I want to run in my development environment. And the last section is a section of commands that you want to expose on the IDE, so that the user can select those commands and will be able to run them with just clicking on a button. So that's pretty powerful. You can also specify extensions, so Visual Studio Code extension that you want to add to your development, to your IDE. In your dev file, you can also specify environment variables, or ports or volumes that you want to expose, that you want to create on your development pods. So it's pretty powerful, but for the typical use case, and we'll do an example, we'll do the demo later. The dev file is a few lines, so like 10 lines or so. So that's it. I would. So David, don't hesitate to interrupt me if you have anything to add.
I will do.
Yeah. Otherwise, I will we'll start with the demo actually. So it's and David, I will let you present that because that's something that you're requesting, right?
Yeah. So in this scenario, we're imagining that I'm a project maintainer. I have an application which is called the Out Yet application. It's a simple web app written in Go, and it basically does a query to see whether a particular version of Golang has been released. Unfortunately, as you can see in the screenshot, it's currently checking quite an old version of Go. So I've shot an email across to my good friend Mario and asked him to take a look at updating this to look at whether we can query for a more recent version of Go.
Okay, cool. So I will try to help you, David. Not sure I'm able to find the problem right away, but let's just open it in Che. So I have a Che instance that I've deployed on my Kubernetes cluster here. So as you see, these are all the getting started. So I'm not going to use the getting started here because I've got actually I'm not using an example from here, but I want to open in a Che workspace this repository that you want me to work on. So I will copy the GitHub URL here, and to open it in the Che workspace, I can just use it. So use a query, what we call a factory. I will open. I will set the URL to the GitHub repository, and I will click here, and that will start a workspace. So what is actually doing here is looking for a dat file in that Git repository. There is no dat file here, so we haven't set it up for Che. So nobody has set it up for Che yet. So, but that's something that I want to fix because I want that then if somebody wants to contribute to the project, you may want to use the dat file and open it in Che easily. So it doesn't find the dat file, but what it will do, it will start a workspace with actually just the editor part without any language support because it doesn't know what language you need to support. So we haven't instructed that. That's something that we can do with that file or with Visual Studio Code extension recommendation that are coming in Che soon, but are not available yet. So it will be just a simple editor with no language support. So let me just check that I'm there is probably something that is preventing the workspace to start. David, do you have a workspace running on that cluster? Just wondering if.
Don't think running on that cluster. Let me quickly check.
To the pod. But so now it looks like it's starting. So now the pods have been started, and the IDE will load in a few seconds. It will clone the GitHub project here, and we should be able to start editing code. So yeah, the project has been cloned. I can see my the source code of the application here. There are just two Go files. Should not be too hard, but I have no way to find like the definition of functions, or I don't have code completion here. So, for example, if I try to log something, it doesn't suggest me anything. I don't have the outline of my file. So I don't have Go support. So it's a nice editor, but I would like to add Go support here. So what I will do is that I will add a dev file. Dev file YAML. And actually I have some notes here. I will take the dev file from here. I will put it here. So it's a small dev file, and I'm adding a couple of components. The first one is the Golang plugin. So it's the Visual Studio Code extension for Go. I'm going to take it the latest version. And I'm also adding the Visual Studio Code GitHub request extension. I'm getting the latest one. I'm just adding those two components. And then I will add a command that will make it easier to do debugging. And it's actually a Visual Studio Code launch specification, so that only instruct to run. So to start debugging with Go, the current file. So I will reload. I will just change the definition of my workspace here. I will reload it. So if I go back here, I can. These were the definition of my current workspace. It only had a project. It didn't add any component or comments. So what I will do is that I will add the components and the comment, and I will just apply it so that it will restart my workspace. So, and the cool thing is that I've created a dev file in my workspace, and I've added some content. Now I'm stopping my workspace. That means that the pod that was running the workspace has been killed, and I'm starting a new one. But the content of the file, the new file that I created, is persisted because the source code is persisted in a persistent volume, so that if you stop and restart the workspace, you will find all the changes, so that I will be able to push to the remote Git repository the dev file that I've just created. So let's now it has stopped and restart with the new dev file. So the dev file that brings the support for the Go language, the GitHub request, and that add a command to debug the application. So the dev file that I've modified before is here. So if I open now my main Go file, and so, oh yeah, he's asking me. So after the pull request plugin, so he's asking me to sign in to GitHub. So I will allow it, and yeah. So I should be logged in now with my GitHub account, and I can use this is the pull request, the GitHub pull request view. Let's go back to the Explorer, to the File Explorer. Now I should be able to see the outline of my file, I can go to the main function here. I can add some, so I can see that now I have some code completion. I should also be able, so this this function here is using this new server function, so I can go to see the, so there is no documentation for it, but I will be able to see to navigate to the definition here. So I've code completion, code navigation, and everything. So you will also be able, you have refactoring, so you can like refactor, rename a function, etc. You have a lot of actions available. These are all provided by the language server protocol. And there are a lot of language server for any language that you would like to run. And with that, you can use language servers on with Che, because these are like services that can run in a container and can talk with the IDE through WebSockets. So that's it. Now I want to. So we've opened it. We know we can edit it. We have coding support, but we want to run it. And I will do like start debugging here. So it asks me what if I want to start. We'll use Go. So yes, I will use Go. He's proposing me to use this launch. Okay, that's okay. Let me just. Right again. So when I start debugging, what it's actually doing is it will compile the code and run it in a container, the container where the language server is actually running, and so a language web application. So the web application built will be run, executed in the in that container, and it will expose a port. So it sees here. So it's now the process is listening on port 8080. So we figure out that it's listening on a port. So we need to expose it to the to make it public so that I can access it to with my browser. So I answer yes here, and I then open the link in my in a preview window. Let's say, so now I can refresh it, and I'm actually able to see the problem. So that actually is looking at the is Go 1.4 out yet? Yes, of course. So 1.4 is many version back. So I can update it. So if I look here, the things is that the first thing that it does is parsing the flags, and the command line flags are defined here. There is HTTP poll version, and the default value for version is 1.4. So if I want to change it with the latest one, let's say 1.15, I can change the code, and let me just stop. What I will do is I will put a breakpoint somewhere here. Yeah, here in the serve HTTP function. And this time I will rerun it with the breakpoint enable. So the application is starting. It asks me again if I want to expose port 8080. Answer yes. I open in the preview window. I'm going to refresh it. It's not ready yet. Yeah, now it's ready. So the application now has been stopped here where I put the breakpoint. I can move it forward. I can see the threads. I can see local variables as well. And here I should see the version 1.15. So that's everything looks fine. And yeah, if I run it, if I resume it, then it shows me 1.15. So at least what David has asked me, so I should have fixed it. I've added the dev file as well. So now he will be able to start it in Che as well. So now I will stop. I'm happy with what I've done. What I can do is that I can open a terminal. The last thing is that I will open a terminal in the Visual Code Go sidecar, and here I will actually in project I will go inside the out get folder. Here is where my source code is, and I can do like a go test to run the test. Because I have a main task go, so these have been run, they pass, so I'm ready to commit, to do a commit here. So I will use the command palette. I haven't shown that yet, but you are able to. So that's really weird here now, because I'm running my slides on my browser, Git repository browser, IDE in browser. So the software to connect to the conference in browser. So everything is running in my browser. But anyway, so I will use the command palette. The shortcut, the keyboard shortcut here are the Visual Code shortcut. I can change the branch, so I will create a new branch. I want to create a pull request. And first I will create a local branch, and when I say local, it's not on my laptop, but is mainly in the Che workspace. So I will create it, and we'll call it dev file. Then, so I can see the new branch here. So I've switched to the dev file branch, and I can open the Git view, and I see that I have two files, a new one that I've added, the dev file and main.go, where I've changed the version, the default version that is checked. I'm going to stage those two files, and I'm going to add a commit message, adding a dev file, yeah, and make it like that. So I've done the commit, and what I will do now, the
smiley face
is
there to help us forgive you for massive scope creep in adding a dev file for just changing the version number.
Exactly. So I hope you will decide if you want to merge the pull request anyway. You're the PM. So once I've done that, I can create a pull request. I choose, so I'm using here the GitHub pull request Visual Code extension. It prompts me for the target branch. So I'm targeting master. I'm using the dev file branch, my local dev file branch. It's okay. It was not able, because I think that yeah. Okay. All right. Let's try to get pulled before. Mm-hmm. So I don't know what's going on here. So dev file, I'm gonna push. So the thing that I can do is that I can push it remotely at least. Yeah. I think that the problem is that I already have there is already a dev file branch here.
Yeah, that could be it.
So I will just remove it, and I will try it again. So I will use the title. I will use my commit title. Okay, cool. So now it's, yeah, it shows me this nice UI of the pull request. So I can, the pull request has been created is the number 4 on this Git repository. I will add a command to the pull request that will help David to do the review actually. So let me copy it from here. I will edit. Okay, so I'm happy with it. So I will then let you, David, review the pull request. So I will stop sharing my screen.
All right, so hopefully my screen is now viewable. Let me know if it's too small or you can't read anything. You should be seeing the out yet repository. I can now see that there is a new PR waiting for me to review. So let's have a quick look at that. I can see the changes that have been made, adding the dev file, but I've also helpfully got this comment from Mario, oops, went too far, to try it out for myself. And this will spin up the workspace just for me. Whilst we're waiting, Mario, there was a question in the chat regarding whether we could migrate Eclipse plugins or whether there's a way to migrate Eclipse plugins into Che. There's a couple of ones that have been called out.
No, we do not support Eclipse plugins. So the way we extend Che today is through Visual Studio Code extensions. Visual Studio Code extension marketplace, it's you have a lot of things. So you'll probably want to look to the Visual Studio Code extensions already existing. So we are not pulling Visual Studio Code extension from the Microsoft marketplace for many reasons. One of those is like legal reasons, but usually all the extensions are have their source code, the source code repository, and they build it the VSX files, and that's where we actually take the Visual Studio Code extension from. So if you are able to get a VSX, you can try that in Che for whatever extension that you may have in desktop Eclipse. But yeah, the technologies that we use, so we are not compatible at all with Visual Studio Code. So with Eclipse plugins, unfortunately. Okay, so yeah, the workspace looks like that's almost started.
Yep.
You didn't eat the problem that I had with.
Hello.
Oh, no,
did you have your workspace still running?
Yeah, that's my fault. We don't have a cluster big enough.
Yeah.
So I've stopped my So you should be able to start it now.
No worries. Now, we're currently running on a fairly small cluster that we only really use for one workspace. But you can see, well, the keen-eyed may be able to see one of the differences as opposed to when Mario started his workspace. Is this message here where it's saying that it has been able to find the dev file. So when Mario started, obviously it was a very simple environment with just the basic editor, and there was no Go language support or anything like that. Whereas the experience for me will be much different thanks to the changes that Mario has made. So I'll already have code completion working and the debugger task defined so I can easily launch it. So by contributing this dev file, what Mario is giving to the project is an easy way for me as a maintainer to then enable any other contributors with the same and reliable development environment so that they can easily check out changes. And we understand that if there is an error, it's not going to be just because of differences in a developer's workstation compared to what I'd been using, for example. Right. So I've got the same message where I will need to sign in. Let's check that's worked. Yep. So I can see the Go file. I can already, what should we do? Let's do, see if I get code completion. There we go. A little slow, but it's working. Everything is all looking good. I can try it for myself. So I'll start the application without debugging. Same message about exposing the ports. Wait for the application to actually come up. Whilst that's doing that, assuming that I'm happy with this contribution, I'm about to go ahead and merge the PR. Something that I could do is make it easier for others to try out this approach by updating the README to include a link for the same thing that Mario has provided me. Let's see if that's actually running. Yes, so I've verified the changes. I'm happy with it. So I should be able to merge that. I'm going to make a change. Remember the actual keyboard. And I'm going to grab some code. So this will just update the README with a simple image which points to basically the same URL that Mario showed at the start, using the factory to create a workspace based on the repository, now with the repo in it as well, the dev file. So if I go to source control, I can add my change to the README, say Sticking with Che link. And I should be able to do, just want to give that for now. Push. And that should.
So you maybe had to move to check out the master branch.
I thought I was on master. Yeah, you're right. So I forgot to check out master, and instead of committed it to the dev file branch, but you kind of get the idea through this anyway. So if someone comes to the project now, they can easily follow the guidance in the README, or I can send an email like I had to Mario with this link in it, and that will allow them to quickly start up a Che workspace for themselves.
Okay, cool. Yeah, that worked pretty well. So I think that we're running out of time. So I would just go back to the slides. So I'll share my screen. Can you see the screen?
Yep.
Okay, cool. So as we've seen, so we've been able to deploy the application, so run the application, develop without actually knowing or mentioning anything about Kubernetes. So no previous knowledge of Kubernetes required. The code has never went into my personal laptop. Always stayed in the cloud. Nothing installed locally. I've run everything on my browser, and as we've seen, we've been able to define the different tools that we wanted and the configuration of the workspace through the dev file, so a YAML file. And so if you want to try Che, so there are multiple options. The easiest one is the version of Che, so that we host in the cloud. On the URL is che.openshift.io, and it's an Eclipse Che that runs on Kubernetes managed by Red Hat. So Che and Kubernetes are all managed by Red Hat, so you don't have to install anything. And you can sign in for free there. Other options are the public cloud. You can install, we have documentation to install Che on AWS, GCP, Azure, or you can install it locally as well with Minishift kind or Docker Desktop. And of course on-prem, on private Kubernetes, you will be able to use or the operator to install it on any Kubernetes cluster that actually allow to install the Helm chart or an operator. That's it. I think we have said everything we wanted to say. So if David, do you want to add something, or if there is any question? We still have a few minutes left.
Yeah, still got 5 minutes. So please, anyone, if you have any questions, do feel free to raise them in the chat.